Hi guys, welcome back to the vector section of the SQA Higher Maths course. Today we are going to look at the angle between two vectors. So in the last lesson we looked at the scalar product in terms of two different forms of the scalar product. So we looked at the scalar product in terms of the magnitude and the angle between the vector. We also looked at the scalar product in terms of the components, if we knew the x, y and z components of each vector. So if we want to find the angle between the two vectors, we can use cos theta equals a dot b over the magnitude of a multiplied by the magnitude of b. Now that is just this formula. Where's it gone? No, that one. Up one more. That is just this formula rearranged to make cos theta the subject. So this is given in the exam. However, this one is not, but just dividing through by AB, magnitude of A multiplied by the magnitude of B, we can get this formula dead easily. Or the other form, we know A dot B is A1B1 plus A2B2 plus A3B3, so we can easily derive that formula as well. So let's go straight into an example. Calculate the angle between the vectors P and Q. So let's have a quick reread of this. So we need to know A dot B, we also need to know the magnitude of A and the magnitude of B. And then we're just going to substitute into the formula. So P dot Q will be, having a look here, 3 multiplied by 4 plus 4 multiplied by 1 plus negative 2 multiplied by 3, which comes out as 10. The magnitude of P will be 3 squared plus 4 squared plus negative 2 squared. Remember to get that negative 2 in a bracket if we're using a calculator. Magnitude of Q will be 4 squared plus 1 squared plus 3 squared, which is root 26. Right, we must rewrite this formula in terms of the given vectors. So we can't be writing A dot B over the magnitude of A multiplied by the magnitude of B. We've got to use P dot Q and the magnitude of P and the magnitude of Q. Because the SQA want us to do that, and if we don't, they will dock us a mark, which we do not want to happen. So P dot Q was 10, magnitude of P was root 29, magnitude of Q was root 26. So substitute the values in, rearrange to make theta the subject of the formula by finding the inverse cosine of 10 over root 29 root 26. And that gives an angle of 68.6 degrees to 3 significant figures. Okay, so what have we really done there? We've done P dot Q, we've found the magnitude of P, the magnitude of Q, and we've substituted in and taken the inverse cosine. And that's us done. That would be 5 marks in a higher maths exam. Question 2. Points K, L and M are given. Find angle KLM. So what I would do here, guys, I would draw a diagram. So it is this angle here that we want. The angle between vectors LK and LM. If you don't draw the diagram there, you might be making a little silly mistake. You might end up calculating the angle at K or the angle at M if you're not joined them up properly. Or you might have the vectors pointing away. So instead of this angle, you would get the angle in here if we extended this line. Okay, so always draw a quick diagram. That will take you 5 seconds to draw. Just do it. So vector LK is K minus L. Vector LM is M minus L. And after that, so the cosine of KLM will be LK dot LM, which we can calculate from here. So 4 multiplied by 5 plus negative 10 multiplied by 2 plus negative 2 multiplied by negative 3, which is 6. We can find the magnitude of LK, 4 squared plus negative 10 squared plus negative 2 squared, all square rooted. Similar way, find the magnitude of LM. And then we're just going to substitute in. Remember to write it in terms of the vectors given in the question, guys. I mentioned this in the last example. You will lose a mark if you don't do this. Substitute in the values, take the inverse cosine, and to three significant figures we have 84.9 degrees. So question 3. Again, this is very similar to something you might see in the final exam. If this comes up, this should be one of your banker questions. You should be getting 7 or 8 marks out of 7 or 8 if we have this extra step at the start. So I will just scroll back up. So the diagram below shows a cube, so if they tell me it's a cube, that will be important. So all the edges will be of an equal length. The point R is coordinates 4, 0, 0. So here's the origin. So point R is 4 in the x direction, 0 in the y, 0 in the z direction. Write down the coordinates of t and u. So how do I get to t I should say? I go O to P, then P to T, so that's 4 in the y direction and 4 in the z direction. There was no movement at all in the x direction. And it also asks for u. So to get from the origin to u, I would go 4 in the x, 4 in the y, and 4 in the z direction. So I have t and u. Part B, find the components of RT and RU. So RT is t minus r, which, well, I've got t here, and we know r from the question, so it'll be 044 minus 400, which will be negative 4, and in a similar way, finding RU, we would get 044. Okay, so if this was an exam, that would be 3 marks worth so far for doing something reasonably straightforward. And part C for 5 marks if this was an exam. Calculate the size of the angle TRU. So again, it's the angle here, so we need RT, we need RU. And we've already calculated those in part B. So cosine of TRU will equal RT to RU over this magnitude of RT multiplied by the magnitude of RU. So calculate RT to RU, which is 32. Find the magnitude of RT and RU, which will be root 48 and root 32 respectively. So I could be simplifying at this point. That would be root 16 root 3, which would be 4 root 3. But because I'm not at the end of the question, there's no need to do that yet. And then substitute in, take the inverse cosine. So inverse cosine of 32 over root 48 root 32 is 35.3 degrees to 3 significant figures. So there we have it, guys, finding the angle between two vectors, a very common exam question. Make sure you do plenty of practice at this, and hopefully it will come up in the exam, and hopefully we will get lots and lots of marks. Have a go at exercise 6C. Just quickly check that. Yep, exercise 6C.